this is a case study more towards a remote production opportunity that we did last year in Europe for the Euro 2016. This is soccer, for those who are unaware of what the Euro 2016 is all about. I'm going to cover what the challenge was, how we solved it, and why we did this with IP. And this is going to be a challenge to do in 20 minutes, but I'll do my bestest. So, okay, hang on. Yeah, someone said the clicker was a bit iffy. Okay, so first off, what is this Euro and how does it work? So basically, it's a soccer event. It's held by, it's organized by UEFA, which is the European Football Association. And our customer was EBU here. So EBU was tasked to provide what's called the VANDA, the video and the audio distribution for this network. Let me see, clicker. Okay, and UEFA then provides these services to the rights-holding broadcasters. So, for example, they could be, I'm just making stuff up, ESPN, Sky, BBC, Swedish television, where I'm from in Sweden. Whoever has the rights to actually look at these feeds. And depending on what rights you buy, you get access to different feeds. So you could get like a base package, or you could get all sorts of a la carte options depending on basically how much money you're willing to spend. So what does this look like? One thing that was unique about the Euro 2016, in difference to, for example, what you see typically in an Olympic event, etc., is that there were venues were all across France. So this was happening in France, and the venues was all across the country. Typically, for events such as these, they're kind of in one city or in one region. But this one was different because the venues are literally all over. So what we had to provide here, what the EBU had to provide, was all these streams from the venues to the IBC, and the IBC was in Paris, and IBC stands for International Broadcast Center. And that also out to the rights-holding broadcasters, or the broadcast partners, who also had the ability to create their own feeds or their own content back to their home country. They also, the UEFA also, UEFA was being the host broadcast. They also produced their own feed, which for people who did not afford, could afford to send someone over to Paris or to France, they could just buy this, what's called the multilateral feed, I think it's called. And you can just buy that feed and they will produce everything for you. You can just add your own commentators on top of it. So these are the locations all over France where the event took place. The IBC was in Paris, and it was connected over 100 gigabit links. So one of the sponsors of the event was Orange Telecom, and they provided dual, or rather redundant, but really dual 100 gigabit links to each venue, out of which this was split into 10 gig links. And we were allowed to get 9 out of those. The 10th link, the 10th 10 gig link, was reserved for UEFA's own testing, some data stuff they did, etc. So we had 9 links to produce all that content. Each venue looked something like this. Oh, clicker. There we go. It had 36 HD SDI cameras. Everything in 1.5 gig SDI. And typically, the way this normally would have been done in, let's take like a Rio, for example, etc., the VANDA's job is to move all this content from the venue into the IBC. They're split everything out, provide it to the different rights holders depending on what they bought, and have them create their own content. Now, traditionally, the problem in doing this historically is that you have, even though these links might be IP, the IBC infrastructure typically looks like this. You have everything is handed over to an SDI router. You have an SDI multi-viewer. And the issue you have is that you have a number of single points of failure. So the SDI router, for example, although they're very reliable, is actually a single point of failure in the IBC. The source or the transmission box at the remote site is a single point of failure, and the receive site is a single point of failure. So even though these are redundant, you have a number of single point of failures here. Now, that's one thing, but even more importantly in this event, one of the main factors why they moved to an all IP solution was because the event was spread out and they had a lack of technical personnel. So the entire Vanda system was supported by 4 engineers. And if you have 10 venues all over France doing at the most 4 events a day simultaneously, you can't have 4 people cover that in case there's a problem. So what they wanted to do was to insource as much as possible into the IBC, keep all the intelligence at the IBC, and basically make sure that everything that was out at the edges was fully redundant and basically foolproof. So how do we go about doing that? So this is basically the challenge. You have 10 venues, you have all these cameras that are out there at the end, which all need to be moved over to the other side. So what we did is that we moved everything over to IP, right? Not surprising. So at the end here, we do dual units. So we take the output of the cameras and the OB, and we do a passive DA. We split this passively, and we send it into like what we call a red and a blue unit. So out at the edge, we have twice the amount of equipment. So the equipment can break. The DAs could break because they were passive, so there's no, in worst case if they lose power, they still have a signal pass through it. You have redundant links, but here at the IBC, we're going to redundant IP switches. So instead of handing everything over into another one of these boxes that then decodes it and sends it over to an SDI router, there's no SDI router. Instead, this is the router. Dual switches, and all the content is on both switches. Now, these devices then are then placed out where the rights holders are in a M+N style scenario. See if I have a slide for, yeah, there we go. So we do 1+1 protection at the edge, but M+N protection at the IBC. So the IBC has a bunch of different rights holders. It has our technical personnel. So we can do something like a 100 receive devices with 10 spares. Right? That's an M+N style redundancy. If you were to do 1+1 redundancy in both locations, it would be incredibly expensive. It could be done, but it's just very expensive. 1+1 redundancy at the edge gives us the ability to be foolproof at the edge, have a normal redundancy at the whatever they're willing to pay for at the IBC, and have the staff there to manage it in case anything breaks. Another advantage we had is because this was all IP now, out at the edge we did something that's been around for absolutely forever, but no one's actually taken the pain to do in the past, which we inserted time code aligned all the feeds. The purpose of this was that traditionally all this would have been stripped off in the DAs at the IBC side before it goes into the SDI router. The intent was, although we provided it, it wasn't actually used, is to do a record of everything. So everything that came out from the venue is record everything. And you have all the cameras had source ID on them. So we would set out here at the edge exactly which camera you're looking at and exact time code. Drive that all down to storage. After the event, we were talking, the previous gentleman was mentioning that you wanted to create some post-event content. Someone can go back and says, show me all the angles from 10 minutes to 10 minutes 15 in this game. And you can see exactly whatever was interesting at that point. So you go from a selective record to a selective delete. Right? Instead of having 12 ingest ports or whatever your amount to record is, just record everything. It sits on IP, record everything down, remove the stuff when you have run out of spaces, delete it. Another thing that this gave us the ability to do is with source ID out at the edge, which sounds pretty simple. It gave the operators over at the IBC the ability to know on the multi-viewer exactly what they were looking at. So in the past, I'm not going to go back, but you remember the old solution which has basically a transport network and then 2 discrete facilities basically. When they were doing patching between events, if someone did a mispatch, you wouldn't necessarily see that because the labeling sits in the SDI router. So if someone mispatches a camera from an event into the SDI router, the operator thinks that this is the camera from Bordeaux, although it isn't, right? So that becomes a big hassle for broadcasters who paid several hundred thousands or millions of dollars, and they want to get their feeds out from this event, and there's someone has done a mispatch, and there's a whole area of operational nightmares that happen. So by doing this and basically carrying the metadata, if you will, all the way out from the source as far as possible into the IBC, that's the time code and the source time, source ID information, we're able to visualize that in the multi-viewer or record that down on the storage to have less operational issues or basically be more effective. Another thing that this gives us the ability to do is that we actually created a multi-viewer out at the edge. So in the past, if you remember, the SDI router was here and the SDI router fed the multi-viewer. Instead now, we created a multi-viewer out at the edge and we transported the multi-viewer stream along with the rest of the content to the IBC. This gives us another advantage when it comes to troubleshooting. Again, an operational advantage. In the past, if you looked at the multi-viewer and there was an issue on the multi-viewer, there was a bad signal or whatever, the issue could have been at the SDI router, it could have been at these termination equipment, it could have been at the links, it could have been at the transport equipment, it could have been at the OB, it could have been at the camera. You don't know. Now that we're continuing to send the multi-viewer, we generate the multi-viewer at the remote event and send it through. If there's an issue at the multi-viewer, they know it is stuff coming in. As soon as it hits the transport equipment here, they will see if the signal is good or not. So again, there was another advantage of using IP in that example. And here you see the multi-viewer layout at the IBC in Paris. And the first row here are a number of gentlemen. They're especially hired in from the UK for every event to do this, and it's the money generation. Right? These guys get a phone call from a BBC and says, give me another feed, give me another camera, because whoever did really good at this game, and that's 200 grand right there. So this first row was extremely important to them. They have to have very fast response if there was any issues, because this is how these guys make money. Here's another example of the setup from the wiring, etc. This is all these sexy drawings. But basically, and I did another presentation yesterday, although this was a remote production event, this is basically a data center with sources across France. So we had basically, if you looked at from an operational perspective, this was a 900 by 900 SDI router, completely over IP, exploded over a country. Anything could be routed to anywhere across France. And I have some slides around the operation. I'm going to skip through this and show you what the operational GUI looked like. So this is a touch panel, which we created using our control system VSM, stands for Virtual Studio Manager. And it looks something like this. In the past, previous lives when the UEFA has done this has basically been a matter of manual patching. Now it took them about 5 seconds to route an event because they knew exactly where the event was coming from and where it was going. So it was very simple, a matter of a source destination take. What venue needs to be routed to what production facility. And actually, I'm going to go back one and show. So this is the venue routing, but I could, of course, press the single routing, and I could do any route anywhere I wanted as well. Again, this is all over France controlled. We also gave them a view of, because this is now cloud, or this is now remote production IP, just a view of where's this signal actually going? Which path is it taking in case I need to send some guy into the equipment room to look at a port or something. But hopefully instead of having to do that, we gave them a good overview of what information they wanted. And these systems, if you look at the broadcast interrupt lab, for example, when you have 20, 30 manufacturers all spitting out all sorts of monitoring information, the question is really, what do you want to monitor? I mean, I've had some guys over there that've been looking at Wireshark, etc., and that is not a very efficient way of doing your fault troubleshooting and your monitoring, right? What you want to do is you want to tell, you want to have your operators just look at whatever is important. So what VSM does, or what VSM allows you to do, is to pull out whatever information you want from any equipment you want and present that in a simple view. So this statistic could be from one manufacturer, this could be for someone else, this from someone else, this from something else, etc. You can combine it any which way you want to make give the operator a really simple look at what's the performance, and also be able to just go in on a particular function, maybe not necessarily even a device, but a function, and look at what's happening in this function, what's the status happening in this function, so we can pull out any information we want there. Here's another view from an alarm perspective. We also gave them various statistics, blah, blah, blah. But another cool thing that we did is that we partnered with a company called PRTG. It's a German company, and they primarily sell their software. They're basically a software monitoring company to the big data center guys. So they're specializing in monitoring links, CPU load on a Cisco switch, etc. And what we're able to do with them is that they could put these monitoring points out, and we would take that information which they gathered and they processed, and we basically just take the output of that and present it inside, I think I have it in, oh, I had it in a previous slide. We present this as a view, which you can see. I'm going to go back, sorry about that. There it is. So that's just another view from the control system. So we take the output from a completely different software and we embed that into our control system to provide a view, a holistic view over the entire network of whatever the operator wants to see. Okay, so what's next? Skipping forward. Blah, 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 management network. And by the way, I think they said it was the largest deployment they've ever had, monitoring over 120,000 different monitoring points. So what's the next steps? The next step is basically IP end-to-end. You saw before we did this SDI conversion. What I didn't tell you was that at the actual venue, all the cameras were already connected to Lawo stage boxes anyway, but that was from a different project, so a different customer. So we had one customer who said, which was the UEFA themselves, who said, please wire all our infrastructure inside the venue together. Then we had another customer who says, can you please talk to UEFA and do a handover? So we basically had a SDI handover here. This is the only point that was SDI between these two networks. So there was really no reason to have it there other than for commercial reasons, because someone was to point the finger at someone. Right? If this breaks, if that breaks, etc. It was different companies providing this. So the next step is really to just, and this is a view of the gateway device at the venue. The next step is really just to do this IP end-to-end, and with the IP cameras, IP vision mixers, etc. We are pretty much there right now. So what you see right here is something we did last year, and the next step now is just IP all the way to the viewers.